Good day, everyone. Today we're going to discuss about our new lessons, but before that, let me read to you our objectives of our lesson today. Illustrate similarity on triangles. Proves the conditions for similarity of triangles. SAS Similarity Theorem, SSS Similarity Theorem, AA Similarity Theorem, and AAA Similarity Theorem. How do we create proportionality statements for triangles? Do you have any idea? Did you know that similar triangles have the same shape but not necessarily the same size? And the symbol for similarity is this one. Let's discuss first the AAA similarity postulate. The AAA similarity postulate: two triangles are similar if and only if their corresponding angles are congruent. Now look at this picture of two triangles. The corresponding angles here are angle C, which is congruent to angle F. Angle A is congruent to angle D. And angle B is congruent to angle E. As you can notice, the two triangles are not exactly same size, but all of their angles are congruent to each other. Therefore, triangle ABC is similar to triangle DEF by AAA similarity postulate. Another example. Now we have here given measures of angles, such as angle B is 30 and angle E is 30. Therefore, they are congruent. Angle C and angle F. And angle A corresponds to angle B. The three angles here and the opposite and the other triangle are congruent. Therefore, we can say that the two triangles are similar to each other. Triangle ABC is similar to triangle DEF. Next, the AA similarity postulate or theorem. A stands for angle. So, we are going to consider only the two angles of a two triangle. So, two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar by AA similarity theorem. So we're not going to consider anymore the third angle, so just focus on the two corresponding angles. So we have here two congruent angles or two pairs of congruent angles from these two similar triangles. Those are angle B congruent to angle B, and angle C is congruent to angle F. Therefore, we can see that triangle ABC is similar to triangle DEF by AA similarity theorem. So, as we all know that the sum of the interior angle of a triangle is 180 degrees, and the sum of these two given angles, if we're going to subtract that to 180, we can get the value of the third angle. And the value of the triangle is congruent to that angle of another triangle. Next, the SAS similarity theorem. S stands for side angle for A and S for side. So if in two triangles, two pairs of corresponding sides are proportional, so remember the corresponding sides are proportional and the included angles are congruent. Alright, so included angles must be congruent here. Then the triangles are similar. Alright, look at this triangle. So we have here two triangles such as triangle BDE and BAC. So in our statement, BD is corresponds to BA. So the total measure of each side, and then and then 2 BC, the total measure of this side. And then angle B is congruent by reflexive property. And we can also make this proportionality statement such as BD is to BA, the part only of the bigger triangle. Next, BF is to FC. And then angle B is congruent to angle B. If you're going to make a proportionality statement, so you're going to look at the sides. Okay? So, and angle must use this symbol, congruent. Therefore, triangle ABC is similar to triangle DBF by SAS Similarity Theorem. Let's move on to SSS Similarity Theorem. If the corresponding sides of the triangles are proportional, then the triangles are similar. So SSS meaning the three sides of two triangles. So as you can see the hash marks here, so we have PO, or the smaller triangle, corresponds to the side of the bigger triangle, which is TA. PO over TA, this one, and the shortest side of the two triangles. Next, TM is to TN. So TM is to TN, the longest sides, and then OM is to AM. So remember, you can do this in any order, that you have to make sure of their pairs, of their corresponding sides. Alright? So we use the three sides of the two triangles. Therefore, triangle TAN is similar to triangle TOM by SSS Similarity Theorem. Now, look at these two triangles. Let us prove these two triangles are similar by SSS by solving the measurement of their sides. So we're going to prove that. So EA is corresponds to SK. So it is 3 over 9. Next, so 80 is to KY. So we have 4 over 12. Next, the longest side. So 80 is to SY. So that's 5 over 12. So you're going to get the lowest term of these three proportion or three ratios of these two triangles. So we must have to get an equal answer. So we have 1/3 for 3, 9, 4 12 for 1/3, and 5, 15 is equal to 1/3. So we solve that. So therefore, our reason here is by computation. So we are able to prove that the two sides are proportional. Therefore, triangle EAP is similar to triangle SKY by SSS Singularity Future. Another. So we're going to prove these two triangles if they are similar according to the measurement of their sides and angle. So I have here a table. So we only have here two given for the sides, which is 4 and 3, 21 and 28. So 4 corresponds to 28, that is DA and to AM. So 4 is to 28, while 3 corresponds to 21, that is DA to AX. So 3 over 21. So you're going to get the lowest term of that, of our ratio. So the lowest term of 4 is 28, divide both by 4. So we get 1/7. Then 3 to 21, divide both numbers by 3, and we get 1/7. Since they are equal by computation, and then angle A of the first triangle and the angle A of the second triangle, since it forms a vertical angles, and according to the definition of vertical angles are congruent automatically. Therefore, we can say that angle A is congruent to angle A. Next. Therefore, we can conclude the triangle EAC is congruent to triangle is here. I think I have here a typographical error. So the triangle here is DBA and the other one is MXA. Alright. So they are similar by similarity theorem because we use the side angle and the side of the two triangles, including these two figures. Now let's review the triangle similarity theorem. The three corresponding sides or the corresponding angles are congruent. It is a similarity theorem. Two corresponding angles are congruent. It is a similarity theorem. Now, if three corresponding sides of two triangles are proportional, it is SSS similarity theorem. And lastly, two-fourths of corresponding sides are proportional and included angles are congruent. It is SAS similarity theorem. Now we're going to solve a problem involving a triangle or similar triangle. So we have here a given the 2-meter tall lady makes a 12-meter long shadow and the palm tree makes an 84 long shadow. What is the height in meter of the tree? So we're going to measure the sides or this part to get the height of the palm tree. So given this triangle. So if we're going to illustrate our given, so we can figure out this one. So similar triangles are used to determine the height of tall objects using shadow tricks because actually we cannot really measure the height of the tall objects unless we're going to use a device. So we're going to use a shadow of another object, which is the tall lady here. So we're going to redraw this into a triangle. So I think this is SAS similarity theorem or triangle similarity theorem. Alright, so we're going to make a proportional statement. Alright, so look at this given. So we have here, so this side corresponds to this side. Therefore, we can write a proportionality statement here. H is to 2 is equivalent to, this one is the base of the biggest triangle and this one is the base of the smaller triangle. So bigger to smaller. So we're going to use that ratio. So bigger, so we have here 84. And then smaller side, that is 12. Alright, so you can use the properties of ratio and proportion to solve this. So I prefer to use cross multiplication. Just cross multiply the extremes. So we have h times 12 equals 2 times 84. So h times 12 is 12h equals 2 times 84. The answer is 160. And then divide both sides by 12 to eliminate the 12 beside h. So we can get h. 168 divided by 12, the answer is 14. So after we solve that, we have to create a therefore statement. So it is therefore, we can use this simple. Okay, the height of a palm tree is 14 meters. Don't forget to write the limit. Alright, that's it. That's how you're going to solve similar triangles. Okay, thank you for listening.